Ignition sequence start. All engines are running.
We have taken tremendous steps.
We choose to go to the moon before this decade is out.
We have achieved the earth-shaking, the breathtaking, the groundbreaking,
One small step for man.
and left a mark in the heavens. Our successes build one upon another and amplify what is possible.
The dawn of Orion.
It's time we take the next great leap. We're building the next chapter of American exploration, returning to the moon to stay, so we can go beyond to Mars, to expand what's possible and further our understanding. The architecture for these missions is already taking shape. We will go with new systems, bold designs, and a sustainable mission. You can hear it, taste it, touch it. We are going. We are training, testing, pressing our pioneering spirit into every component, defining our resolve with every line of code, and securing our success with every welcomed partnership. This is not hypothetical. This is not about flags and footprints. This is about sustainable science and feeding forward the advance of the human spirit. Because we are the pioneers, the star sailors, the thinkers, the visionaries, the doers. And because we stand on the shoulders of giants to go farther than humanity has ever been, we will add our names to the rolls of the greatest adventurers in history. Every day, every mission, we advance this calling. We are NASA. And after 60 years, we're just getting started.
And as we leave the moon, we leave as we came, and God willing, as we shall return.
You probably dreamed of this.
Liftoff on Apollo 11.
You probably replayed this moment 1,000 times.
Four wheels off the ground air.
You probably imagined the awe-inspiring, indescribable rush of the ride. You probably celebrated the miraculous, cheered the momentous, and mourned the shocking. You probably still dream of what could be. We did. We do. And while many thought we were through, no. We've been learning, we've been building, we've been training. And now, it's time. Because the next frontier is not just for the next generation. It's for this generation. It's for me, and it's for you. For everything we still dream about. We go as Artemis.
We're going to the moon to explore, and we're going to the moon for scientific discovery.
Our destiny is always to go and see what's further and what's next.
The moon is a stepping stone, and the moon is a place we need to learn how to live so that we can continue to go beyond.
We are focused. We are focused on all that lies before us. Only together will we bring to life this global ambition of returning to the moon. And while our work is far from finished, we've never been closer to seeing a new generation step beyond our home planet. We are building on the achievements of those who came before. The giants who conquered gravity and raised a banner in the heavens. They beckon us to go farther, to the moon and on to Mars, to seek a deeper understanding of our universe and bring all that we learn home. 2020 was a year of unpredictable hardships, and yet, step by step, we resolved to press forward toward this grand vision. The daily efforts of thousands of suppliers from all across this country and around the world fed into stunning milestones and laid the groundwork for history.
Launch team, go.
Artemis has been woven into our culture. It has fostered collaboration across the aisles and across the ponds. It has grown beyond plans and preparations to include hardware and software. And now, it has a heartbeat. You can feel the momentum. It is undeniable. We are going. And together, we will see Artemis light the way.
Our mission to the moon is no longer some far-fetched dream. This is reality. We are going.
This is the next step in evolution.
They're not just PowerPoint slides. They're actually metals being bent, shaped, formed to build the things that we're going to use.
This is real. This is going to happen. We're going.
We are going to the moon to learn how to live on other planets for the benefit of all.
Let's go.
Three, 2, 1, 0. Ignition, liftoff.
Artemis I will lift off from Launch Pad 39B at NASA's Kennedy Space Center in Florida with 8.8 million pounds of thrust, provided by the most powerful rocket in the world, our Space Launch System rocket, or SLS. The uncrewed flight will be the first integrated test of SLS, our new Orion spacecraft, and exploration ground systems at Kennedy. Artemis I will send Orion beyond the moon, 280,000 miles from Earth, farther than any human spacecraft has ever flown.
This is not NASA doing this. This is the United States of America doing this program, the Artemis program, and there are companies all across our country that have a part in it, so there is kind of this wave of excitement being generated just by saying, we're going back to the moon.
After the upper stage of the rocket separates from Orion, the upper stage will deploy small satellites over several days to perform science experiments and technology demonstrations. Orion will make its multi-day outbound trip to the moon, propelled by a service module provided by the European Space Agency. Engineers will test Orion's systems on the way to the moon. Then, Orion will fly about 60 miles above the lunar surface, using the moon's gravity and engines on the service module to enter a lunar orbit. After about a month and a total distance of over 1 million miles, Orion will return home, faster and hotter than any spacecraft has before. A primary goal of Artemis I, ensure Orion safely returns to Earth before we fly with humans. When we do, we'll build our capability for sustainable lunar exploration, preparing us for missions farther into the solar system.
Initially, what we'd like to do is start establishing a presence on the moon. So we're going to establish going back there on a regular basis, and then we'll end up setting up Gateway, and we would launch to the Gateway, and from Gateway, land on the surface of the moon.
We are there for, weeks, months on end. And there, we're going to be able to test out all the hardware and the habitats and the hatches and the suits and the rovers that'll allow us to prove out those technologies. The moon will lead the way to Mars, and we should be there within the next couple of decades.
Between 1968 and 1972, America launched 9 human missions to the moon, 6 of which successfully touched down, allowing 12 men to walk on the lunar surface. NASA's next chapter of lunar exploration, called Artemis, has the task of not just going to the moon to create a long-term human presence on and around it, but also to prepare for ever more complex human missions to Mars. In short, everything we must be able to do here, we must first do here. So, what will an Artemis mission look like? Everything is designed and tested with our most important element in mind, the astronauts. This is their deep space, human-rated spacecraft called Orion, built in 3 parts. The crew module, where up to 4 astronauts will live and work throughout the flight. The service module, with life support systems for the crew and its own engine and fuel reserves. And a launch abort system, with engines capable of pulling the crew module to safety during launch should anything go wrong. To accomplish the task of launching our crew and heavy payloads, NASA is building the Space Launch System, comprising of a cargo hold, an exploration upper stage, a massive core stage, and 2 extended solid rocket boosters. Altogether, this is the world's most powerful rocket, and it exceeds the legendary Saturn V of the Apollo era in numerous ways. Sitting on the launch pad, the entire rocket, fully fueled, weighs just over 6 million pounds, 5.2 million of which is just the fuel. Once ignited, there is no stopping what comes next. All 4 RS-25 engines and the 2 solid rocket boosters come to life, thundering our crew upwards. 2 minutes after ignition, the solid rocket boosters are spent and released. 8 minutes after launch, the core stage is depleted and separated. The upper stage fires briefly, placing Orion into a parking orbit around the Earth. Here, the crew reconfigure the spacecraft and check systems to confirm everything is ready for deep space travel. With a go from mission control, the crew reignite the exploration upper stage engines to leave Earth entirely. The exact timing of this maneuver is critical to reach a speed that can escape Earth's gravitational pull, but also put Orion on a course that will intersect the Moon days later. Once this burn is complete, the upper stage of the SLS is jettisoned and the crew aboard Orion coast for several days toward all that awaits them at the Moon. Approaching the Moon, we see the fundamental differences between Artemis and Apollo. Instead of requiring Orion to serve as an expendable lunar command module or to carry a constrained lunar lander, the Artemis missions will take advantage of a different approach: pre-staging. Everything needed for lunar missions will be positioned in advance by commercial and international partners. This includes rovers, science experiments, and human-rated systems on the surface. But it also includes a dedicated lunar station in orbit around the Moon called Gateway. Here at this station, we can pre-stage a robust lunar lander and establish a strong communications relay. Designed with open standards, the Gateway can be expanded as new missions and partnerships develop, allowing multiple human missions on the Moon at the same time and enabling ongoing science to be conducted even between human missions. The Gateway is also capable of adjusting its orbit to allow access to every part of the Moon, something the Apollo missions could not do. But the real key in this approach is placing Gateway in a unique halo orbit to perfect the maneuvers needed for Mars missions. And with the growing list of commercial and international opportunities, Gateway is the ideal hub between Earth and all that lies beyond. Returning to our crew as they approach Gateway, the Orion must match the elliptical orbit of the station in order to successfully dock. Once on board, pre-selected crew members transfer to the lunar lander, while those assigned to Gateway remain on station. The lunar lander system itself is built for 3 unique steps: descending from the halo orbit of Gateway down to a low lunar orbit, descending from low lunar orbit to the surface, and once the lunar mission is complete, launching from the surface of the Moon and ascending all the way back to the orbiting Gateway. Once back aboard the Orion spacecraft and undocked from Gateway, the crew fire their engine once to break out of the halo orbit and once again to sling the spacecraft around the Moon, placing it on a multi-day trajectory back towards Earth. As they near the end of this journey, the service module is released, and the crew module is oriented heat shield first. Entering Earth's atmosphere at 25,000 miles per hour, the friction of air slows Orion considerably, while also subjecting it to temperatures of 5,000 degrees. With the Orion now at just 300 miles per hour, a series of parachutes uniquely tested and produced for this moment deploy, decelerating the craft to just 20 miles per hour for splashdown. With each successful mission, Artemis ushers in the next wave of men and women to explore our Moon and prove that together we are ready to go beyond.
So you want to go to Mars. How does NASA's International Space Station help us extend human presence into deep space? In the future, when astronauts land on Mars, it will be thanks to some important lessons that we learned on the International Space Station. Rewind. 240 miles above the Earth, the International Space Station is where we currently live and work in space. Here's what we've learned so far. First, there's taking care of our astronauts. Prolonged weightlessness can lead to muscle and bone loss, vision changes, balance, and coordination loss. Thanks to the space station, countermeasures are being developed to keep astronauts healthy for long-duration missions. Then there's the equipment. Spacecraft communication, water recycling, air, and power production are all being test-driven on the International Space Station. What we learn about operating and maintaining our gear in the harshness of space will pave the way for future missions into our solar system. And that's how the space station is helping us extend human presence into deep space. For more information, visit this NASA website. So you want to go to Mars. What does it take to be a NASA hero? Meet the heroes behind the scenes who make deep space exploration possible. People often think of astronauts as heroes, and they are. And they will be the first ones to tell you that there are many other people who make space missions successful. On Earth, there's ground support, the folks responsible for launch and landing. Heroes work in mission control and keep a watchful eye on the astronauts and spacecraft 24/7. Heroes design, test, build, and fly the rockets and spacecraft that take astronauts off our planet. And there are heroes who make spacesuits, habitats, and equipment for the astronauts to live and work on the Moon and Mars. Human spaceflight is possible because of the heroes on the ground and behind the scenes who build the technology and systems needed to send astronauts into the solar system. Will you be a NASA hero? For more information, visit this NASA website. So you want to go to Mars. How do we send humans to deep space? In order for humans to explore the Moon, Mars, and beyond, we need safe, flexible, and powerful systems that will make it all possible. We start with the world's largest spaceport. At Kennedy Space Center, we have all the buildings and tools needed to assemble and launch space vehicles, and have the teams in place to recover the astronauts when they come home to Earth. Next up, we need a deep space rocket. This is NASA's Space Launch System. It will be the most powerful rocket NASA has ever built, and it has the muscle to lift people and all of the equipment needed for missions to new worlds. The Space Launch System will blast off with the crew in the Orion spacecraft. The most advanced spacecraft ever built for human exploration, Orion provides the life support, power, communications, and other systems to safely transport astronauts on a variety of exploration missions, like to the Moon. In lunar orbit, we will learn to live and work in a deep space environment, something we have never done before. In future missions, NASA's Gateway will be a place for astronauts to live, work, and prepare for missions deeper into the solar system. There you have it, NASA's Deep Space Exploration Systems, charting our new future in space. To find out more about deep space exploration, visit this NASA website. So you want to go to Mars. How does NASA's history prepare us for future exploration? NASA has been exploring space for 60 years. In that time, we've learned a lot that will help us with future missions. First, NASA learned how to build and launch rockets into space. Then NASA learned how to send astronauts, who performed spacewalks, rendezvous and docking maneuvers, and tested new technologies to prepare us to go to the Moon. During the Apollo missions, humankind explored the lunar surface and proved that we can walk on other worlds. After the Apollo program ended, NASA returned to low Earth orbit, but with longer, more complex missions. Skylab, America's first space station, taught us important lessons about living in space. The Space Shuttle kicked off a series of regular missions advancing astronaut training, launch capabilities, and on-orbit operations. The Space Shuttle enabled us to build the International Space Station, expanding our ability to use space for scientific research and teaching us how to make a permanent home away from Earth. Astronauts still live there today. Building on 60 years of knowledge and discovery prepares us to go farther than humanity has ever gone before. To find out more, go to this NASA website. So, you want to go to Mars? Go with a friend. Do you know why NASA has been successful in sending humans and robots into space? It's because NASA doesn't do it alone. NASA has partners. Commercial partners, those whose business is space and engineering, have always contributed to NASA. That role has expanded. Commercial crew and cargo vehicles bring people and equipment to and from the International Space Station. On the space station, global partners from around the world join with NASA to conduct scientific research and explore off of our home planet. That type of cooperation will continue with future space missions from the Moon to Mars and beyond, as international partners contribute components for NASA spacecraft and equipment. NASA partners with universities, research laboratories, and even other government agencies to help expand technology development. NASA partners with schools to reach out to the next generation of scientists and engineers.
3, 2, 1.
So as you can see, NASA doesn't go at it alone. It has partners. When traveling to space, go with a friend. You'll find when you work together, you will go farther. Find out more at this NASA website.